Welcome to this video. This is Mark Scythian. The date today is January 27, 2021. This video lecture will focus on creating a formula to calculate calorie consumption while running on level ground. So the following scenario, we have a 160-pound individual who runs 1 mile over a 7-minute time period on level ground. So we can write an equation so that walking, running, and jogging on level ground can universally be calculated by the formula here in green, which has been derived from the following data. We have a 160-pound individual, convert that into kilograms, mass, 5,280 feet to a mile, would convert that to meters, and then 7 minutes is 420 seconds. Next, we calculate the average acceleration, d divided into t squared, as opposed to the dynamic acceleration, which would of course be 0 if the speed of the runner is constant. Since we're getting an average, it would be a constant regarding dynamic acceleration, but the average acceleration will be a value very close to 0. So then we can multiply that times the mass to compute the propulsive dynamic force, the average horizontal force the runner is being propelled based on the average run step impulses, which then is multiplied times the distance divided into the time to compute power. And then we have a equality of 4,184 watts. It's also equal to 1,000 calories per second output. So we compute a very tiny amount of kilocalories per second output times the number of seconds, and then convert that into calories by multiplying times 1,000. So the given runner will consume 260 calories over the given run. So therefore we've proven the metrics to create a formula which was derived through algebraic and power rule summation. This has been reduced for simplicity with all the different exponential values canceled out and the reciprocals quantified to derive a clean, easy to use formula. So if you are walking, jogging, or running on level ground over a set distance over a set time, and you're curious about the amount of calorie output or the calories you're burning, you can use this formula here in green, which is 1,000 times the distance in meters squared times your kilograms mass, or your pounds divided into 2.2, which is the mass, then divided into 4184 times the seconds of the run duration quantity squared. Additional information: a calorie is defined as the equivalent heat energy required to raise 1 gram of water mass by a temperature of 1 degree Celsius in the metric system of measurement. A unit of potential energy and energy density of a fuel, food, or electrical source, whereas a calorie per second is a unit of kinetic energy or power output, in which 1,000 calories per second power output is equal to 4,184 watts. The US English equivalent to the calorie is the British thermal unit, or BTU, which is the equivalent heat energy required to raise 1 pound of water by a temperature of 1 degree Fahrenheit in the US English system of measurement. A unit of potential energy or energy density of a food, fuel, or electrical source, whereas 1 BTU per second is a unit of kinetic energy or power output, in which 1 BTU per second power output is equal to 1,056 watts of power. So this formula will work to compute calorie consumption when walking, jogging, and running on level ground. Thank you for watching this video, and have a great day.